Thank you. Thank you all. I love watching Kath. I've seen Kath present a couple of times, and it's interesting moving from the microbiome into the environment in which we operate, which is the macrobiome, which is our environment. Our corporate presentation, I was going through this a bit earlier today, and I realized that we had this important notice that everyone has to pay attention to. You've got to look at it very closely and make sure that you read all the small words, and that as Kath says, everything I'm about to say is not really verifiable. But the reality is that this notice is not nearly as important, in my mind, as this notice. So this notice came out this past Monday, which was a climate change report from the United Nations that said basically, we've got 12 years. 12 years to figure out what we're going to do about our climate. What are we going to do about our environment before we start a downward spiral from which we can't return. So I don't know about you, but 12 years ago, my daughter was 12 years old. You think back 12 years, how quickly that goes. 12 years is next to nothing, and we are facing a crisis. We're facing a crisis in this world regarding global warming, regarding climate change, and regarding one of the fastest growing resources in the world. It's interesting to me the AIM is predominantly a resource-oriented trading market, and our earlier speaker was talking about resources, and we're talking about the microbiome and the macrobiome, but the resource in which we're dealing is waste. And waste is growing at a rate faster than the human population is growing. And as the human population grows, the demand for energy continues to grow. Our population is doubling every 35 years. The average waste per person is a bit under 2 kilograms per day. And the energy demand that we're looking at is going to double in the next 14 years. So how do we meet those objectives while still protecting this macrobiome? How many of you happened to see earlier last week the BBC show Drowning in Plastic? Anyone? Few of you. How many happened to see Blue Planet? Quite a few more. 16 million people watched Blue Planet. Only 2.5 people watched Drowning in Plastic, unfortunately. The reality is plastic use is growing dramatically. And it's continuing to grow, even though those of us in the Western world recognize that the management of plastic is a challenge. It's created a scourge. I like to say we're not in a war against plastic. We're in a war against the mismanagement of plastic. 8 billion tons of plastic has been produced to date. 8 billion tons. And 95% of that plastic still exists. It's still here and degrading and collecting in our environment. Currently, about 10% of plastic globally is recycled. Only about 20% of all waste is recycled. Less than 50% of waste worldwide is utilized as an energy source. 38 million plastic bottles in the UK every single day. Some of these things just make you shake your head. 1 tire for every man, woman, and child reaches the end of life every year here in the UK. And what do we do with those tires? Only 15% of them are recycled. A lot of them are burnt. I don't know if you've ever seen a tire burning. It's a horrific sight. So we've got this set of choices about what are we going to do about waste management. How are we going to manage our macrobiome? And so the end of product life for waste is, of course, wherever possible, we want to reduce, we want to reuse, and we want to recycle. The challenge that we face with recycling is it's very energy intensive. It's still an emerging suite of sciences. There's significant challenges facing some of the types of materials that we'd like to recycle or like to reuse. Another choice is energy recovery. So instead of simply having reduce, reuse, recycle, we need to be looking at recover as well. So we recover energy from it wherever we can. And a major component of energy recovery is incineration. Now, the problem with incineration is it's a very massive project, hundreds of millions of pounds to get an incinerator going. Many of them are being denied permits. People don't want an incinerator in their backyard. The energy conversion in incineration, while it's increased dramatically over the last number of years, is not nearly what it could be if we take advantage of some of the advances that we've seen in technology over the last few years. And of course, where we least want to see waste go is to landfill. What we want to do is we want DMG, distributed modular gasification, the PowerHouse energy process that allows us to recover the most energy value possible from end-of-life products with high calorific values, things like end-of-life tires, things like plastics. We can do this on a small footprint, a half-acre site. We can integrate this in an industrial complex. It's an amazing process. And what's more important about it is that it allows us to extract hydrogen from the effluent that we create. We create a synthesis gas we call ecosynthesis. And the difference between the synthesis gas that our process creates and the synthesis gas that has been part of other gasification projects historically is that we operate through a series of temperature envelopes that allows us to create a synthesis gas that does not retain entrained tars and oils through the process, and it allows us to then extract a pure stream of hydrogen. Hydrogen is, a report came out a few weeks ago or a couple of months ago that hydrogen is going to be necessary for us to achieve our global climate change goals. For us to get to the objectives that we've set for ourselves for 2022 and 2025, we're going to have to engage hydrogen in our economy. And where that's going to be engaged is going to be in the transport sector. I'd like to say this is a picture of my car, but it's not yet. But the important thing about this is that the tailpipe emissions when utilizing hydrogen is air and water. So the hydrogen economy is actually starting to unveil itself around us. We're seeing hydrogen buses in London. London has a fleet of 8,500 buses, of which only about a third are hybrids, 50, are battery, and 12 at this juncture are hydrogen. They recognize that the battery-powered buses face some significant distance challenges. They face some significant weight challenges, and the hydrogen bus will allow them to operate all day, be refueled in a normal fueling process rapidly, and be back on the road. More importantly, we're starting to see major industry invest in large purchases of fleets of vehicles. This is a picture of a Nikola 1 HGV. Anheuser-Busch ordered 800 of them, pre-ordered 800 of those to start toting beer around the USA. It's a significant investment that's being made. 10.3 billion euros has been committed on the part of 39 companies in the transport sector, in the oil sector, in manufacturing throughout the EU to begin opening the hydrogen economy. So our process, distributed modular gasification, I say at times that PowerHouse Energy, the PowerHouse Energy Group is an 8-year-old company that went public about 8.5 years too early, right? So we're just about to turn the corner. We're just about to hit commercialization. We've gone down a number of blind alleyways. We've gone down a number of pursuits to achieve the kind of energy objectives that we wanted to achieve in producing both green electricity and hydrogen. We have, over the last 18 months, been building our team, bringing on a new chairman, bringing on a commercial manager, building out the engineering team, getting the pieces in place to really turn this into the commercial endeavor that it needs to be. We're now in site-specific engineering with a number of early adopter customers, and we're in the midst of planning and permitting for a site up here in the Northwest. Now, we've got a process demonstrator facility down at the Thornton Science Park, the old Shell Research Center, so along with Kath, we're also local residents. I, as you might tell from my accent, didn't actually grow up in Manchester, but we're operating out of Chester and out of Thornton. And my wife and I have actually relocated here to the UK in the anticipation of the commercialization process. So the important thing is that there are challenging wastes that we're creating. And those wastes are going to be created regardless of what we do, regardless of how much we attempt to reduce and reuse and recycle. There are going to be components of the manufacturing process from which we're going to need to work on recovery of the energy value that is contained within them. And we want to do that as efficiently as possible. And so we have spent the last 18 months testing down in Thornton, testing our demonstrator and building the commercial model that allows us to comfortably hand our entire commercial design off to a third-party engineering validation firm who is in the process of writing a report saying, you know what, this stuff actually works. So we're pleased about where we are, and we're pleased about the impact that this can have. And we believe that bigger is not necessarily better when it comes to waste management, when it comes to creating a product that can be used near to a neighborhood, in an industrial park. We don't need it to be 300 miles away and be transshipped over a transmission line or through a pipeline. If we can create it around the corner, safely and securely, and deliver it right there with no transmission loss, and take care of a growing and burgeoning problem, which is this out-of-control mechanism of waste growth and plastic growth. And even though everybody is committed to fewer plastic bags and fewer milk bottles and fewer plastics throughout the process, there is going to be plastic that needs to be dealt with, some of which is not going to be recyclable. 5% of cars are made of plastic, and they're not recyclable. That plastic needs to be handled and dealt with in some way, and we can take that plastic and extract 50% of the energy value as hydrogen, which can then displace a fossil fuel. And so when we displace a fossil fuel like diesel, we're displacing 23.5 pounds per gallon of CO2 that's generated when you burn diesel. So the impact that we can have by having dozens of these small footprint, small capex, under 8 million quid for one of these, to take care of a massive problem. And when we look at what needs to happen on a daily basis for this facility to operate, is we need a single truckload of waste. We need a single truckload of plastic to come in through our DMG system, generate in excess of 1 ton of hydrogen, generate in excess of 28 megawatt hours of electricity, which is going to be powering 1,500 homes, which can produce 6,000 HGV miles. There were 14 billion miles driven by HGVs on UK roads in 2014. And that was the last year in which data was available. And then, of course, excess heat that we produce, we can use locally in a wide variety of ways. So when we look at the general economics and the number of revenue streams, we get paid to take this waste. It's the way the waste industry works. We get paid to accept this plastic, anywhere from 30 to 200 pounds per ton, to accept our plastic, to run it through our DMG process, and then we get paid to sell it. We get paid for the hydrogen, we get paid for the hot water, we get paid for the electricity. And the interesting thing is that, of course, if you look at these numbers, you recognize that the biggest piece is hydrogen, right? And this is at 5 quid a kilo. Hydrogen's currently selling for 12 pounds per kilo. And so we thought, well, we'll take a conservative estimate. That, the numbers there allow this machine to operate without hydrogen. So this completely washes its face until the hydrogen economy comes upon it and says, I want your hydrogen now. Then we can start delivering hydrogen because we built a distributed modular system that allows us to put piece by piece by piece by piece together like Lego blocks. So we have a facility that's focused on thermal conversion. We have a component that's focused on controlling the process. We have a component that's focused on generating electricity, and we have a component that's focused on purifying and extracting hydrogen. And those are all independent modules that can be integrated into any facility, in any industrial facility. So we don't need the hydrogen to make a business case for the facility. What we need is the hydrogen economy ultimately to make the world a better place. There are huge numbers of opportunities for the company in terms of both licensing our technology, building regional franchises. Our objective is to roll this technology out as quickly as it can possibly be. Someone was asking about how one takes advantage of things commercially, and the idea is this is a big pie. We're going to create a pie that's big enough for everyone to share, and we're happy for people to be involved in looking at this almost as a franchise. So we're currently at the market entry phase where we're focusing predominantly on plastics. And one of the reasons we're focusing on plastics is because there's a lot of attention that's being paid to plastics. We've been talking for nearly 3 years about the need to manage plastics more effectively. And I don't believe that the right way to manage plastics is to convert them back into diesel and then convert that diesel into more carbon dioxide, particulate pollution, and nitrogen oxide. I believe that taking that plastic and converting half of it into hydrogen, which diverts diesel, is the right approach. Now, there are other mechanisms by which we can recycle plastics and turn them into other components, but the maximum number that plastics, and maximum number of times that plastics can be recycled is something in the neighborhood of 8. And so once you've achieved that, you've gone through plastic bottle, plastic bottle, plastic bottle, it's no longer recyclable. Something has to happen to it, and I'm saying let's turn it into hydrogen utilizing our DMG process. So as we look at the rollout and we look at our order book building and the number of people who are acquiring about our technology, because they're all everywhere in the world is facing problems with waste. The fact is that we've got plastic piling up in recycling yards here in the UK. We've got plastic piling up at transfer stations. We've got plastic piling up in council facilities here in the UK. And we're the guys that have all of the technology. This stuff is happening in an exponential fashion around the world. So we're trying to create a technology that can be rapidly deployed in an inexpensive manner, producing a fuel for transport and for fueling people's homes and for creating electricity in a way that doesn't harm the planet. So if we got 10% of the UK waste plastics alone, just 10%, we could build 60 of our distributed modular gasification units. So these things operate on 25 tons a day. Again, single truckload. 90,000 homes could be powered, 30,000 gallons of diesel. This is per day that we can do this with 10% of the plastic that is currently piling up in the UK. So we really believe in responsible economic energy recovery. I don't believe that you can build a company that's focused on the environment that is not sustainable. And the only way a company can be sustainable is if it is profitable, if it generates profits for the shareholders, if it generates returns so that we can reinvest, so that we can continue to roll out and we can continue to build. We've got a phenomenal set of directors. We've got a great management team. Most importantly, we've got a technology that we now know works. This was published in The Guardian earlier this week, and I just wanted to kind of circle back as we start looking at the macrobiome. The idea is we want to keep things under 2 degrees. We want the increase of the Earth to grow less than 2 degrees higher than it was at the beginning of the Industrial Revolution. The reality is we're already at 1. So we're not starting back here at 0. We're already at 1. And the expectation is that by 2030 or 2040, if we don't do something dramatic, we're going to be at 1.5. And then it's going to spiral. And so impact on tourism, who cares? The fact is it's going to start killing people. We start looking at the summer. We had a lovely summer here. There's a massive hurricane that's blowing into my former home of Florida today. Perhaps the biggest hurricane that's hit Florida in over a decade. Now, there's no question in my mind that it's somehow related to changes in our climate. It doesn't matter whether we created climate change. It doesn't matter if that's a man-made problem. It truly doesn't matter if we are the ones who have gone out and precipitated this. But what does matter is that we are the only species on this planet that can do anything about it. We're the only ones that can take a step forward and start producing something, eliminating the waste, reducing where we can, but recovering in a responsible manner to create a fuel that will fuel the future and allow us to reclaim our planet. Thank you.
Yeah. Lovely. Keith, thank you very much.
Yep.
Do you have any questions for Keith, please? Gentleman here, please, Chris.
Organic compounds consist of carbon, hydrogen, oxygen, and nitrogen.
Yes.
So if you're producing hydrogen, where's the hydrogen coming from? Are you breaking a carbon-hydrogen bond, or is it coming from the water?
At times it comes from the water, and at times it comes from the carbon-hydrogen bond. So when we're looking at long-chain hydrocarbons like plastics or tires or bunker fuel or some other hazardous waste, there's a lot of excess hydrogen.
What happens to the carbon?
The carbon is typically combined with oxygen that comes through the process.
To produce carbon dioxide?
To produce carbon monoxide, that is a fuel that is then run through a gas generator. That produces carbon dioxide. So there's no question that carbon dioxide, this is not a silver bullet, right? This is not the silver bullet. This is not a mechanism by which no carbon dioxide will be produced. It is, however, a carbon neutral process when looked at in toto. If you look at displacing 500 liters of diesel with 1,000 kilos of hydrogen on a daily basis, and you do the sums, you find out that you're in a carbon neutral situation. So we're able to generate 6,000 miles of transport without any emissions by utilizing this process.
Okay, so you're breaking carbon-hydrogen bonds by using, what, a noble metal catalyst or something?
No, we're actually just doing this in a thermal conversion process.
For a bit of a layman,
Yes.
a thermal conversion process.
Heating it
Very
really hot.
basically, what's the technology? How does it work?
Okay, you take something and you put it through into our thermal conversion chamber, which is exceedingly hot. It's operating at above 1,000 degrees C. And the energy that is then imparted into that waste product allows things to, and forgive me, the doctor in the room, but it effectively allows things to demolecularize, right? It allows the bonds to break, allows them to separate and then reconstitute as carbon monoxide, as free hydrogen, as methane, and come through as this ecosynthesis gas. From that gas, we then run it through a variety of processes to ensure that there is no longer any entrained tars or dioxins or benzenes. In fact, most of those cyclical aromatics or any of the toluenes or difficult carcinogens that one would find in petrochemicals are broken. The chains are broken and they are rendered inert in the process. So you end up with a gas that you can utilize that is a safe and effective gas when managed properly.
Any other questions, please? I was going to ask Keith, you mentioned the firm's been listed for 8 years, and you said 8.5 years, too early perhaps. How long have you been with the organisation, and what's your background?
So I'm a trained biologist out of Stanford University. I've been involved with PowerHouse for about 6 years now. I came on board to help babysit the company through a serious transition that it went through with the team that took it public, the team that started working on the technology, and the team that ultimately failed. Over that time, what we've done is slowly but surely chipped away and taken advantage of advances in material sciences, advances in energy efficiencies, in technology, and found people with whom we could partner and work to achieve this DMG, this distributed modular gasification process, and in which we're achieving an energy output that is 85% from the 100% that's going in, right? So in 25 years ago, when the idea of thermal conversion was first considered, it actually required more energy input than was coming out. Now we're at a process where we're looking at a parasitic drag, effectively, on the whole process of about 15%.
So by that you mean for 100 units of energy that go in into sorry, just say it again.
Yes, okay, so 100 units of energy go in, 85 come out, but they come out in a different way. They come out in a usable way, they come out efficiently, as opposed to 100 units of energy going into incineration, 28 come out, right? In our process, 85 come out. In landfill, 0 come out. Now, there is some methane gas that can be recovered, biogas that can be recovered in landfill, but that's not being done very effectively. In fact, landfill is one of the largest contributors to methane emissions on the globe. And so wherever possible, we want to eliminate landfill. And landfills are being closed all over the world. And so, in fact, I think there's only one left in Ireland. So we have to find mechanisms by which we can take care of this waste, and we can't dig holes and drop it into the ground any longer. And incineration, while it has its place in the grander ecosystem of waste management, does not efficiently produce energy. It's not the most efficient mechanism by which energy can be produced. We believe our process is the most efficient, and it's the most appropriate for things like plastics and like tires and like oils and things of that nature that incinerators were never designed for.
Do you have any other questions, gentlemen here, please, Chris? If you can reach over. Oh, sorry, no, white shirt, yeah.
I've just got one question for you, something I picked up on earlier. Hurricanes apart, why on earth did you move from Florida to Manchester?
You know, I moved here because I believe in this, to be honest with you. As I said, I've been with the company about 6 years, and I I've operated in energy a few years out of my career, about 5 years out of my career before I got involved in PowerHouse. And I had a chance to go do something with a little company in Silicon Valley and become employee number 10 with them. And instead I got into the energy industry. And turns out that that's one of those forks in the road that one could have taken. That company was Facebook, and I chose to get into energy. And the good news is I'm loving what I'm doing, and I'm intending to leave a legacy. Right? This is a step in the right direction. This is not the end goal. This is a step in the right direction. Us being able to take care of this and deal with this problem and deal with plastics. The fact is there's 300 million tons of plastic that's going to be generated next year. Virgin plastic. It's going to be created next year. 300 million tons is the equivalent mass of every man, woman, and child and microbiome on the earth. Right? And so plastic is not going away for a long time. There's feedstock there that needs to be dealt with. And it's creating significant, it's wreaking havoc with our marine ecosystems. It's wreaking havoc with our environment. We don't even know the impact that it has. We know that something in the neighborhood of 30% of all of the fish that are captured in the waters around the UK have plastic in their systems. Yes, sir. You have to wait for a microphone. You've got one. Great. Yes.
Have you built one?
Yes.
How big?
So we've built it's a 1 to 3, nominal 1 to 3 ton per day unit. It's a process demonstrator. We now have the commercial design for our first commercially operational facility. We expect that to be up and running by, hopefully we'll be breaking ground by the end of this year, early next, and we'll have it up and running within 6 to 9 months thereafter.
How much
Here
money have you got?
We've got a runway, let's put it that way. We've got enough money to feel quite comfortable, and we've got very supportive shareholders.
How much do you want?
I would say that it's going to take us about 3 to 4 million quid to get to our final result.
Okay, Keith, are you going to be joining us for a drink?
I'm not sure that I am, but you all, anyone, feel free to get in touch with me through, I would imagine these guys will tell you how to find me. But thank you all for being here, and enjoy your break.
Okay, thank you very much.
I think it's time.
Thank you. Next and finally for this evening, we have